Welcome to The Explainer. Today, we are diving into a hidden dimension in data, and that dimension is time. We're going to explore technology that doesn't just give you a picture of today, but shows you the entire story of how we got here.
So let me ask you this. Imagine you're a detective, right? The clues to a huge crime are scattered all over the place, not just in different locations, but across different moments in time. A tiny move on Monday, a completely unrelated-looking event on Wednesday, and then the final piece falls into place a month later. If you can only see today's evidence, how on earth could you ever connect those dots?
And that's the fundamental problem with how we usually look at data. A static view, a snapshot, is like seeing just one single frame of a movie. Sure, you see what's happening right this second, but you're completely missing the plot, the entire story of how all those pieces came together.
To really get what I'm talking about, let's zoom in on a really high-stakes example, trying to bust a sophisticated financial fraud ring. See, this is how modern fraud works. It's not one big, obvious heist. It's a slow burn operation. You've got dozens of accounts, and yeah, they're linked by shared devices or payment methods, but those links might only exist for a few hours or a few days. They make these coordinated money transfers that, if you look at them one by one, seem totally normal. To a standard database, this whole operation is practically invisible. And hey, don't just take my word for it. Industry experts like Neo4j put it really bluntly. These networks are designed to change and hide in time. Trying to catch them with today's tools is like trying to catch smoke with a net. It's not going to work. The old way is broken.
So, what if you could fight time with time? What if you had a piece of tech that was basically a time machine for your data, letting you see all the patterns that everyone else is missing?
Well, it's called a temporal graph platform. Now, I know, the name sounds a little intimidating, but the idea behind it is actually super simple. It creates this living map of how everything is connected. People, accounts, devices, you name it. And here's the crucial part. It records every single change to that map over its entire history. This right here, this is the easiest way to think about the difference. A standard database, it gives you that one photograph. It answers the question, what's happening right now? But a temporal graph, that gives you the entire movie. It shows you how connections were made, how they changed, even why they broke apart. It doesn't just answer what is, it answers the much more powerful questions, what was, and most importantly, how did we get here?
So what's its core superpower? Well, it's a simple two-step knockout. First, it maps out that whole web of connections. But second, and this is the real magic trick, it lets you rewind time. You can ask your data questions as of any moment in the past and see the world exactly as it was back then.
Now, this all sounds pretty powerful in theory, but how does it actually change things in the real world? Let's take a look at how this data time machine is solving problems that we used to think were impossible.
So let's jump back to that fraud ring we were talking about. With a temporal graph, an investigator can now just rewind the clock. They can ask something like, show me all the accounts that shared a device in the last 6 months, even if it was just for one day. And suddenly, bam, the entire hidden network just lights up. And we are not talking about some small improvement. Look at this, 50,000. That's how many hours of investigation Zurich Insurance saved in a single year using this exact approach. I mean, just think about that. That's the kind of power we're talking about here. Okay, so it's a total game changer for finding hidden criminals. But what about problems that affect us every single day? Like logistics. We all know how frustrating a delayed package is. But what if a company could actually predict that delay before it even happens?
A temporal graph basically creates a digital twin of the entire supply chain. You can trace any shipment at any point in the past, analyze old data to see how, for example, a concert downtown always messes with traffic, and then simulate new routes to avoid those delays in the future. You can finally see the hidden bottlenecks in the whole system.
And the financial impact is just huge. By using this temporal view, one parcel operator was able to cut their missed deliveries by 76%. The result? A savings of over 3 million euros every single year.
This ability to trace cause and effect over time is just so powerful. Okay, so let's take it from the highway to the factory floor. In a giant plant filled with thousands of sensors, how in the world do you predict which critical machine is about to break down?
Well, you connect all those streams of sensor data to a graph of the equipment. And now you can trace the exact chain of events, that tiny vibration increase, that little temperature spike that led to a failure in the past. By spotting those patterns when they happen again, you can predict and prevent future downtime before it even starts.
From financial fraud to machine failure, we've kind of been hunting for invisible threats. So let's look at one last really critical area: cybersecurity. When a data breach happens, the #1 question is always the same: how did the attackers get in?
With a temporal graph, you can map out your entire IT infrastructure. This lets your security teams trace those really slow-moving, multi-step attacks that are specifically designed to look like a bunch of unrelated minor events. You can instantly audit who had access to what and when, turning what used to be a forensic nightmare into a simple query.
So, you see the pattern here, right? Whether we're talking about finance or logistics or cybersecurity, the same thing keeps popping up. The truly complex problems aren't about isolated points of data. They're about the web of connections between them and, crucially, how that web changes over time.
And this brings us to the single most important takeaway from all of this. If your problem is built on complex relationships that evolve and change, you absolutely need to see the whole movie, not just one fleeting snapshot.
So I'll just leave you with this final thought. If you had this power, if you could see the complete history of every connection in your business, in your research, or just in your world, what problems would you finally be able to solve?